Hey, good morning, everybody. How's things?
George.
Hey, thanks for arranging the technical stuff, Snake Brothers down there in Banderas. And we got people from all over the world here as usual with the Cosmic Summit crew. We got Mark over in Australia and Jahannah and Martin in Great Britain. And then Luke here in North Carolina, Randall down in Atlanta. And Ken, where are you? You're in Ohio?
No, Kentucky.
Yeah, you're in Kentucky right now.
Teach in Ohio, but I live in Kentucky.
Well, we are going to bring a lot of people together from all over the United States, and it seems like about 10 countries now, right? 1 week from, right? What is it? Thursday, yeah. Friday. We got 8 days.
Yeah.
And we're going to kick it off in Asheville, and we've got about 370 people coming. And they are just as excited as you can be. And we can see that on the Telegram thread that we started for attendees. People with tickets are all jumping on a Telegram thread and arranging hikes and dinners and party in my room and all of that kind of stuff. So people are already getting fired up in advance, and it's neat to have that communications channel. But what I wanted to do today was get together and just kind of talk about our presentations, talk about our subject matter. And I don't know, give a little bit of the vibe of the theme of really a thesis, which is bringing together PhDs with hard science and data, along with people that speculate on what the implications of that data may be. And we've kind of got a balance of that at the conference, so kind of 2/3, 1/3. But we think that's a popular format, and it certainly brought a lot of people in, and it's selling some live streams. And I want to remind everybody that this can be viewed live stream next weekend, and it also video on demand. So you would keep the recording forever for $49 if you want to join us next week. And there'll also be a very active social media interaction that Jahannah with how to, where people are going to around the world are going to be asking questions and participating, best we can remotely. So it's really exciting opportunity to buy the live stream. And there are also still some physical tickets available. If people were interested in this last week, bring it on. Let's kick it off here. And I just wanted to kind of ask, I wanted to start with Dr. Moore, if I could. Dr. Moore, when did you first become aware of the Younger Dryas impact hypothesis?
I think it was about 15 years ago. So I was by no means the first reader of the Firestone paper that triggered all of this in the scientific literature. But members of his team, whom I knew independently, came to me and asked me if I would like to participate in the inquiry. And the reason for that was I'd excavated a site in Syria that was occupied during this event. And they knew that, and they wondered whether we might be able to link the occupation on that site with the asteroid or comet collision that they were investigating from a geological perspective. And then everything that I've contributed since then has really been tied to that theme.
And Abu Huraira was a very significant site prior to being connected to the catastrophe. Tell us a little bit about it and why it's so prominent. And that might be difficult to do because it is one of the most important archaeological sites in the world, and you're responsible for it. So put aside any humility and tell us why it's important to science.
Well, we excavated Abu Huraira as a salvage project in the Euphrates Valley, where the Syrian authorities were building a dam. This was back in the 1970s. So we're talking about a project that's now half a century old. But we ran it as a research project. So we saved very large samples of everything that we excavated for later investigation. And that has really paid off because in the last decade, we've been able to go back to soil samples that we collected all that time ago and look at them with this new perspective in mind. But the site is important because it was founded by hunters and gatherers who later got into farming. And as we looked at the remains from the site, we were able to trace the impact of the Younger Dryas through the plant remains that we had recovered, because we saw a change in vegetation. We had good radiocarbon dates. We were able to tie that into the chronology obtained from the Greenland ice cores. So long before any talk about comets and airbursts, we already had evidence for a major vegetation change tied to the Younger Dryas, and with that came the hunters and gatherers turned to farming. So we had hunters and gatherers on the spot turning to farming, and that's a unique event on an archaeological site anywhere in the world, and that's why the site is so important.
And when did they turn to farming after the catastrophe?
Immediately. We
That's
think
astonishing.
from the radiocarbon dates, we had already decided that this must have all happened in a single lifetime, that there was a climate change, there was change in vegetation, and of course that meant that people, if they were going to stay there, had to change their way of life. And so what they did was to get into farming.
So farming and agriculture may have been born of catastrophe, at least at that location,
Now
right?
it begins to look like that now. So we had this astonishing coincidence of the shift from hunting and gathering to farming that coincided with the onset of the Younger Dryas. Well, that was too strong a coincidence to ignore. Clearly, the one was triggering the other. It was a major reason why people turned to farming. But it was not for us to investigate what caused the Younger Dryas in the first place. That was really for the geological community. And they've now come up with this new perspective, which ties it to the Earth bumping into this comet and causing worldwide ecological catastrophe. Well, if, as seems likely, that was what started the Younger Dryas or triggered the Younger Dryas, then it had this knock-on effect of making it necessary for people in the Euphrates Valley to start farming as a way of dealing with the entirely changed environment that they found themselves in.
And what was the first evidence that came back? I'm sure as somebody who managed that site for 50 years, you were open-minded, but perhaps a little bit skeptical that you might have missed something so dramatic. What piece of evidence, when it came back, did you go, holy cow, these guys are onto something?
Well, we had a burned level in the relevant deposits. But that's not unusual on a prehistoric archaeological site. People were lighting fires all the time
Right.
for cooking. If you live in a simple community, and this would be the case right down to the 20th century, you need a cooking fire simply to prepare your daily bread in whatever form that took. So burned levels were not unusual. This was a bit thick. But it was very concentrated outside the front door of the dwelling, the pit dwelling that we were excavating. So I interpreted this as simply campfires, cooking fires, and we published it that way 20 years ago. And I was reasonably happy with that explanation. What other explanation could there have been? And I was a 27-year-old graduate student when I started digging that site. And if as a 27-year-old graduate student, I turned around and declared to the archaeological community that I actually thought what I was digging up was evidence that a comet had destroyed my village, my career would have ended there and then. But however, that never crossed my mind at the time. This perspective came in much more recently, just in the last 15 years or so. And it's caused us to revisit the evidence and to see whether, in fact, we had just misinterpreted what we were looking at, and that this new explanation would fit the case rather better. And that seems to be so.
On the subject of reevaluating evidence and looking at things that we thought we understood, but then finding new information about them that changes your mind, it makes me think of your work, Ben. You've gone back and looked at artifacts, jars, vases from pre-dynastic Egypt, particularly those found in Saqqara, that have been known for centuries, but they've never been looked at forensically in the manner that we can now. Just as Andrew went back and looked at his existing evidence and found a new interpretation, you've kind of done the same. Could you tell us a little bit about your work with the scanning the Egyptian artifacts?
Yeah, sure. I can't take credit for it. I'm kind of reporting on it more than anything, but
yeah,
I've got to thank the guys that kind of have got their hands on some of these, pre-dynastic artifacts. I mean, there does exist, at least to me, that there seems to exist an interesting class of artifacts that come to us pretty much all around the world, but particularly from ancient Egypt, that in some ways seem to defy a technological timeline. These are some of the very oldest of artifacts in the timeline as we know it, yet they appear, at least to the eye, to be sort of the most sophisticated and advanced forms of stonework. And you know, it's all been eyeball judgment and kind of, you know, initial observations, but in recent times, we've managed to get our hands on a couple of these artifacts. In fact, several more now that the project's been
Well, I was
continuing.
going to ask. I was
Yeah.
hoping there are more in the queue. Yeah,
there definitely are. The response to, I mean, we essentially we started with one vase, like a pre-dynastic rose granite vase, that's been in private collection for a while, and we were able to scan it with structured light scanning, which essentially gives you a point cloud, a reference model for the vase that's accurate down to the thousandths of an inch or you know, that type of level. And then it was analyzed for sort of geometric precision. We could do a lot of analysis based on that model to try and understand and you know, essentially reverse engineer its manufacturing process. And kind of the results came in and they were just astonishing, just from a geometric perspective, in terms of the perfection of different elements of the vase relative to its center line, relative to its surfaces, which we could, you know, define by matching geometric shapes to different portions of the vase. That was the initial findings, and that was alone was enough to kind of really start to question, I think some of the narrative around how these things were made. It seems to us and to a lot of experts and engineers and people very familiar with machining and working in difficult materials, that this was already far beyond, I guess, what you could expect to achieve with you know, the tools of the Bronze Age or anything really done by hand for that matter. But as a result of this project, I was very keen on open sourcing the model, and we did that. You can anyone can go and download this model and take a look for themselves. And as a result of that, we actually had a Danish cryptographer take a look at it and sort of analyze it from a mathematical perspective and a geometric perspective. And he ultimately reverse engineered this vase to find that you can actually represent this vase with essentially an elegant series of equations. And he built a CAD model based purely on the equations that he calculated represented this vase, which is a system that seems based on radians or on pi. It's a very geometric model of mathematics. And he found that, you know, the vase itself deviates from the model, you know, in like 10 microns or less. So it seems to have been designed and represented. It really is. And the consequences and the kind of the flow on chain of effects as a result of that are quite startling. And it's very difficult to argue with, because again, all this data is open sourced. You can look at it yourself, but I think to some extent, we're only just scratching the surface on these types of artifacts. I think this type of analysis could probably be applied to a whole category of other types of artifacts to see if this mathematical system was in fact part of the design of other artifacts. And we're starting to proceed down that path now, starting with the smaller objects, the vases. We're trying to get into museums to see if we can work with some of their artifacts as well. But yeah, we're going to get into some of those details at the talk at the Cosmic Summit and I guess what they mean, because it's honestly nothing really short of revolutionary for our perspective on ancient machining and the creation of some of these artifacts. And, you know, I'd have to remind the audience also that these artifacts go back, at least in Egypt, to thousands of years. They've been finding for thousands of years in burials that existed in pre-dynastic times. So before the dynastic civilization ever began, we've been finding these artifacts in burials that, you know, in some cases, you know, there's a site called Toshka that was found. It's now submerged after they built the Aswan Dam that was excavated in the 60s. But they found, you know, it's a primitive burial, a guy in a fetal position with some very primitive handmade pottery. But in that burial, they found essentially precision stone jars. And they've been finding, and that site's dated to 14,000 years old. And they've been found consistently in burials, right, leading up to, you know, the beginning of the Egyptian civilization. The vast majority of them, 40 to 50,000 of them, were found beneath the step pyramid of Djoser, which is a third dynasty structure. And they more or less, those sort of very hard stone precision jars disappear essentially from the record after the Old Kingdom. The fourth, fifth dynasty, they kind of peter out, and the Egyptians shifted to this handmade alabaster version, which is like it's like a loss of capability that all of a sudden happens if you believe that they were the ones making them in the first place. I'm not convinced of that after this research, but it's been a really very interesting journey to try to peel back the layers of the onion on the manufacture of some.
Is it correct to say that the manufacturer of the vase are not acknowledged to be responsible for any of the megalithic architecture. So you have the most perfect art or manufacture, but it precedes what we all understand to be, the most traditionally exciting thing about Egypt, which is the monumental construction. But these two things are disconnected in time, correct?
It does seem that way to me, and this will be a theme for the presentation, something I'm calling a tale of two industries. There's a to me, it's a pretty big contradiction in the story of ancient Egypt, in that some of the most difficult achievements, the things like giant single-piece palm-shaped granite columns, for example. I mean, these exist from the earliest times, the Old Kingdom. The most megalithic architecture, the granite of the Great Pyramid, the granite casing stones of the second and third pyramids. This is all stuff that happens very early on, and you don't typically see that type of architecture in the later periods. It's like they peaked really early at least in the standard model of history, and it's sort of, but if you look closely at them across these categories of artifacts, be it boxes, columns, vases, slabs, megalithic architecture, there does seem to be these two industries. There's one that very much matches the capabilities of a Bronze Age culture, and we can see that. And then there's a whole other class of stuff that also happens to be the oldest and coincide with the earliest parts of this civilization that are very difficult to explain through sort of Bronze Age, our understanding of what they were capable of. So yeah,
Ben, I cannot wait, and I highly recommend your 3 videos on the subject of the scans, where you bring on the experts and the technicians who are just as mystified as you are. They do not have the answers, right? In fact, their surprise is palpable.
It really is. And these are professional metrologists and engineers that work in the aerospace industry. They're making jet engines and rocket engines. They very much understand what precision and what it means and what it takes to machine precision parts. And we're seeing precision that's equivalent to our very best manufacturing systems today. So 5-axis mills making parts for jet engines, the type of precision that is required for that type of stuff is legitimately what we're finding with the analysis of the very first vase we've looked at. And I personally don't think we found a unicorn on the first try. And at least from my initial, just an observation of what I've seen in museums and the number of artifacts that are out there, I suspect we're going to see similar results when we get into some of these other artifacts, and that's the process we're going through now. And in fact, we're even, we're putting some of these things through CT machines, which is an even further degree of resolution, gets us down to about a micron of resolution. Some massive models. I know Kyle's seen one that's these huge models of these vases. It should allow for some really interesting analysis, and that's, we're trying to open source that and do it.
And when you say precision, can you put it in like layman terms for us average Joes? Like, how precise are we talking about precise?
Well, I mean, it's a great question. So if you think about, we talk about thousandths of an inch, like the average human hair is between 2 and 3 thousandths of an inch thick. A sheet of printer paper is maybe 6 to 7 thousandths of an inch thick. We're seeing precision, at least even on that initial scan of the first vase, we're seeing geometric relative precision of different shapes of the vase, different parts of the vase within a single thousandth of an inch, like the resolution of the scan. It's essentially perfect for the resolution we've got. So it's not something that's perceivable by hand or by eye, but you when you measure the bottom of the vase and you fit, say, a cone or a sphere to a part of it, and you can figure out, well, that part of the vase, its center line, its parallelism, or its perpendicularity relative to the top of the vase or the mouth of the vase is within a thousandth of an inch. I mean, that's nothing that's achievable by hand. I defy anybody to try this.
And usually such perfection is intended for some type of use, that you have to have it perfect, but there's no obvious use case to make it that perfect in those times.
They're showing off.
Well,
they're showing off.
Potentially.
Flexing.
It's certainly true that there's a relationship between precision and function. If you look at the development of precision in our modern world, it was born out of the need for more accurate naval cannons, and then the ability to make, chronography, like watches, and keep time.
Yeah.
And in the modern times, it's born out of the need to, develop these nanometer processors for microchips and transistors getting so small. Like it costs billions of dollars to develop this degree of precision, but we do it because there's a return in function in terms of, power efficiency and the footprint it takes. So you don't develop this type of thing for no reason, which does lead you down a road of thinking, well, if you see this precision that's been applied or developed and it's reflected in objects like these giant single piece stone boxes, for example, then they must have had a function. There must have been a reason to develop a manufacturing process that is this precise.
Hey, Randall, I was just wondering, and excuse me, Ben, but I want to get Randall's take on it. Seems like it embeds sacred geometry, which is a broad term, but a field that Randall's been both expert in and interested in for 20 or 30 years, right? And have you seen some of Ben's jar work, and do you have any insight on why it may reflect certain aspects of sacred geometry?
No, well, I would be surprised if it didn't, but I haven't had the opportunity to really analyze Ben's work yet to see how it would apply. I've generally looked at it on the architectural level and how it was used throughout architecture, various cultures, and then also how we find it embedded within the natural world and how that may have served as an impetus and inspiration to ancient peoples to utilize it. But then there's also just a basic set of principles and practices that would be fairly easy to rediscover independently. So whether it's a unified system or groups are rediscovering it independently, I don't have any firm conclusions on that.
Yeah.
It starts with as far as how artists or architects would have used it, it starts with a compass and a straight edge on a piece of paper in the Pythagorean sense. And then it could expand to the use of a pole or staff inserted into the ground, and then a knotted rope or a linked chain or some means of drawing out these geometric patterns onto the building sites.
Hey, Scott Wolter, how are you? Thanks for joining. Yeah, you're muted right now.
You're
Thanks
on
for
mute.
joining us. Yeah. Thanks for joining us from the road. Hold on, Scott, you're on mute.
How about that? Can you hear me now?
Yeah, you're doing
Yes.
great, buddy. Hey, how are you?
Right. Well, good morning. I'm doing good. I'm sitting in the car waiting for Haley Ramsey to show up so we can start our pilgrimage of the day. We're driving up to Austin, Texas. We're in San Antonio right now, where I'm going to catch a flight to go to Los Angeles, where later on this afternoon, I'm going to do a sit-down interview with History Channel for an episode of History's Mysteries or something like that. But
Yeah.
It's going to be a busy day, but I'm excited to be here with you.
Well, thank you for joining us, and kind of on the subject of live investigations, kind of like Ben has underway, where he is developing data, as the conference is going on, and before and after. Yep. You've kind of got a live program underway as well. Could you give us a little insight to your talk, your subject, and where you stand in your 20 years of research?
Oh goodness. And you told me we got to keep all these little sound bites under a minute.
We're going to keep it concise, under 5 minutes.
I know. Fun. Well, actually, I am crafting an email right now to one of my good friends and colleagues in this research, a guy by the name of Alan Butler, who's a British researcher who, in my mind, is one of the, if not the experts in the true history of the Knights Templar Order. So I'm crafting an email. I'm going to be sending him a working manuscript that I'm just about done with right now. And I was just working on that. But basically what's going on in a nutshell is my whole journey with this material started with the Kensington runestone, a controversial artifact that came into my laboratory back in July of 2000. Now that's 23 years ago. And we did an analysis. It was highly controversial. The world thought it was a hoax. I knew nothing about it. We did our forensic work, geological work on the stone, and I concluded that it was not a hoax, that it was genuine. And that triggered a huge backlash that prompted me to figure out, why am I getting all this pushback? We did good scientific work. Why are people having a problem with it? Well, it wasn't the scientific work that was a problem. It was what the conclusion and what it does to the historical narrative of this artifact being authentic. And basically what it does is it blows the narrative to bits. And so for the last 23 years, I had been trying to track down and answer three basic questions. Who were these people that made this artifact? Where did they come from? And why did they come to the geographic center of the continent in North America? The runestone is carved in Old Swedish, so obviously they came from Europe, in Northern Europe. And I think we're getting to the point now, because of many tranches of documents that have come forward over the last 10, 12 years, especially in the last 4 years, that have really opened up a story that is borderline unbelievable, but actually fits together beautifully. The evidence is falling into place. It's like a giant jigsaw puzzle. We know what the image is. We're just filling in those last few pieces. And the story it tells is,
It's
call me
jaw-dropping.
biased. It's amazing. And you've
No,
heard
I heard your presentation in Arizona, and we had already discussed you speaking. And I said, my gosh, I have really lucked into a wonderful new addition to the cast here. I mean,
Yeah.
It is exciting stuff. And do you still have translations of some of the diaries of Henry Sinclair kind of going underway?
Yes.
But you haven't.
You know,
released them.
I know the audience here doesn't know what we're talking about, but there was an interview that you listened to of Diana Muir talking about the journals that she came into. Oh God, it's probably almost going to be 10 years no, she came into them in 2005. But in any case, she has translated all of the documents. I have seen some of the documents, and we have been vetting them since 2016. And basically what's happened is this is one set of documents. I have, I call them the 3 pillars of research. The past research that I've done on mysterious artifacts like the Kensington runestone and others that are connected to these orders that are really the basis of what we're studying. Then we have the Sinclair Weems journals, and then we have something called the Cremona document, which is the material that's come forth here in the last few years. But what's happened is, through the investigations both internally within the documents, the internal evidence is just astounding. It's massive. But what's happening is the 3 sets of evidence of these documents are all corroborating independently each other. And it's all coming together beautifully. In fact, that's the chapter that I'm writing in the book right now, is what are these different key pieces of evidence that show up in all 3 of these sets of documents. And it's really quite astounding. And I just don't know how it would be possible for an army of people to create something that's fraudulent. There's just too much here, too many connecting threads with real history. And we've also been out in the field and found artifacts in the field that we were led to by these documents. So that's pretty compelling. And there's a lot more work to do. So as you said, this is a live investigation. There's a lot more to come, but we've got a ton of material to share. And it's going to be a hell of a story. And anybody that misses it is really missing out.
That's great, man. We cannot wait. Hey, Randall, tell us what you and Scott have in common.
Well, I think we concluded, Scott, that there's 3 things, right?
Yep.
Okay, we both love rocks.
Rocks is number 1.
Geology. Yep, we're both rock hounds. We're both members of the Masonic Brotherhood. And
That's
we
correct.
really got to know each other at a Masonic retreat. We met before that at a conference briefly, but got to know each other at a retreat up on the St. Croix River, wild and scenic river, 4 or 5 years ago. And the third thing is that we're both from Minnesota.
Yes. And we're Viking fans, right?
Well, we were. I mean, yeah. I'm
Randall,
a Georgian
Randall.
now.
Randall, what happened? You still have purple in your veins. Tell me that.
Well, there's still a little in there, you know. I'm still a Twins fan. Okay.
Okay, there you go. That's good. That's good.
Yeah, it was
Anyway.
the year that the Twins played the Braves in the World Series. I was torn down the middle.
Yeah, I bet. Well, we got them that time.
Yeah.
Randall, y'all share an interest in the Templars as well, right? And
yeah.
the Holy Grail.
Oh,
and
yeah.
the
I mean,
quest.
I traveled around Europe back in the 80s, exploring those ideas, going to visiting Templar sites, reading up on the history of Templars. It was kind of combined with my interest in Gothic architecture. So
Yeah.
it seemed like there was an important role for the Templars in the cathedral building era.
Yeah.
And a lot of unexplained things involving the great cathedral building era, primarily the level of expertise and social organization required, the resources, the finances, all of that. And so many of the unanswered questions about that seem to lead right up to the Templars' doorstep. So that's kind of my interest in that really stems from, you know, the mid 80s, early 80s, and then travels in Europe in the later part of the 80s.
Well, that's great. And I look forward to, you addressing some of kind of Scott's subjects as well as the catastrophe and precursor civilizations and whatnot, because you happen to have a big overlap, with his work and have been working on it for years too. But let's switch gears a little bit. Chris Cottrell, are you ready? I don't mean to just pop people on, but kind of on the subject. So go ahead and get ready with your mic. But I wanted to, on the subject of kind of reevaluating existing evidence and, letting the data lead you to new conclusions as you continue to research it. You are an expert in the Carolina Bays, and your understanding of the Bays shifted dramatically a few years ago. Could you give us a little insight to your intellectual journey with that geological feature?
Yeah, I mean, as you know, the Carolina Bays could be pretty controversial, especially when it comes to the dryas impact and the science that are involved and whether we can prove that like the Carolina Bays are part of that story, or if they're not, it's equal, right? Yeah. And so my presentation is going to be looking at, first, where do they come from? And right now, a wind and water explanation doesn't add up, and it kind of ties into the precision that Ben was talking about, and how these are mathematically elliptical depressions that are just covering the entire East Coast. They're out in Nebraska, and they're not the oriented lakes that you find up in Alaska and Siberia places. They're different. They're not the same thing. So we're going to look at that first, and then we're going to look at the timing of that. We're going to look at, could this be part of the Younger Dryas story, or is it not part of the Younger Dryas story? And look at evidence of that. Especially looking at, ancient shorelines that we find along the East Coast of the U.S. and really trying to put a date on when these things could have appeared. And I really think that once we do that, the puzzle pieces start to lock back together. And I'm hoping that's where we can go with it. So,
well, it could certainly use more attention. I've called the Carolina Bays the crazy ant in the attic.
Or the kooky caboose, right?
Or the kooky caboose. That's right. But for the scientific community, they just don't want to hear about it. Better left unsaid. That they're very, very shy about addressing the subject of the Carolina Bays, because if you take it too
and there's such a dominant feature. There's such a dominant feature in the landscape, and they are completely ignored. They're completely
150
ignored.
million Americans live within 50 miles of the Carolina Bay and don't even know it. And that's always kind of frustrated me. And I think it's an amazing mystery. It's accessible to damn near everybody. So it's great that you're getting the word out and have done so much good science communication, just as you do in your teaching career, that you're a true representative.
And that's how I plan on looking at it and presenting it, is taking it back to the basics and just using the processes of science and the scientific method and applying that to the formation and the dating of these things. Because that's what I teach in my class. We start off with the basics. We start off with the scientific method, and basic physics. And you know, I think the story is pretty complicated. So
yeah, no doubt. Yeah, well, it's
go.
an enigma in a box wrapped in a riddle, a little bit. I think it's the way they say it. Hey, Martin Sweatman, how are you, sir? Thanks for joining us from Scotland.
Hi, George. Yeah, I'm fine, thanks.
Yeah, we look forward to welcoming you to North Carolina next week. Have you spent much time in the States?
Not a great deal, a few scientific conferences, but I haven't really seen much around.
Okay, well, we look forward to having you. And Asheville's a beautiful place. I tell you what, you're going to love it. And tell us a little bit, talk about kind of taking a different take on available evidence. Is your work with Göbekli Tepe and your interpretations of the symbology and the carvings on the T-pillars at Göbekli Tepe. I know it's complex, but you've probably learned to summarize it over the last few years. I hate to put you on the spot, but could you kind of summarize your perspective on Göbekli Tepe and your conclusions and how you reach them using the scientific method?
That's a complicated story.
You gotta give 3 minutes.
Yeah, so
it's a probability exercise, correct?
Well, yeah. So you can look at the pillar, the main pillar there, pillar 43 at Göbekli Tepe, but there are other pillars that are important as well, and you can match the animals that are on that pillar with the constellations in modern software, and there is such a good match that it seems very likely that this is not a coincidence. And in the first paper that we published on this back in 2017, we had one way of trying to measure this correlation using some kind of statistical idea. Recently submitted and having peer review another paper which uses a slightly different approach, but overall it's the same kind of statistical idea, which we think is a sort of better attempt at this. But along with that attempt to make a statistical case for this pattern matching, in sort of recent years, I've done a lot of reading. I've learned a lot since starting this whole thing. A lot about the astronomy, a lot about the archaeology, about the geochemistry of the impact as well. And I've learned so much, and I'm still learning. And so now, as well as that statistical aspect, there are other kinds of evidence that are all coming together. So we're trying to link, well, first of all, trying to find evidence for astronomy, both before Göbekli Tepe and after Göbekli Tepe in nearby cultures, and also trying to find links with the symbolism in the Göbekli Tepe area with both later cultures in the Fertile Crescent and with earlier Paleolithic rock art. And so we're kind of drawing together symbolic links between earlier and later cultures, as well as the statistical case. And it's all pointing towards this idea. But also there are other pillars at Göbekli Tepe which shouldn't be forgotten as well, which also add to this story.
And what was your conclusion? What did you think they were trying to communicate at Göbekli Tepe? Give us the punchline.
Well, our view is that
pillar 43.
Pillar 43 is essentially a memorial, we think, to the Younger Dryas impact. And the date of that memorial is written on the stone in terms of precession of the equinoxes and constellations. And the constellations they were using seem to be very similar to the familiar constellations that we know today. So that's how we can do this, how we can see this match in the patterns. Of course, that was controversial because there is a story, the sort of conventional story for the origin of the Greek constellations, is that they originated probably in Babylon or that region in perhaps first, maybe the second, maybe the third, perhaps even the fourth millennium BC. No one really knows because it's a difficult line of investigation to pin down. So this is all conjecture, this sort of conventional story. So this challenges that view, of course. That's the point.
Hey, Mark, you're the representative from the Comet Research Group, which is the informal group of scientists around the world that have been publishing papers providing evidence that there was a tremendous catastrophe 12,800 years ago. Could you give us, for those that aren't initiated or might just know a little bit about the subject and want to know more, could you take up the same challenge, Mark, whether you can kind of summarize the Younger Dryas? Then I want to ask about your own research and where that's heading. But tell us about the Younger Dryas impact and the work of the Comet Research Group.
Yeah, so I'm going to be presenting both the history of the Younger Dryas impact from when it was first proposed through the premature rejection and give a preview of the upcoming research that's coming through the pipeline. Yeah. So sorry, go on.
That's fine. That's fine. There's a little glitch there. But and what's your laboratory work that you do? Like I called in on the other day and you were sitting at the microscope. What are you doing at that microscope?
Yeah,
and
so
how
at the
can a
moment,
microscope tell you anything about a comet impact?
So yeah, when these events happen, they leave behind microscopic evidence, and that's basically how we know they happen. So I was isolating carbon spherules and glass-like carbon from both the impact and the wildfires that followed. And I've also been doing work with magnetic microspherules. I did my bachelor's research on that, and particularly the failed replications in the early work. I was aiming to characterize why that occurred, and it's been quite interesting.
You have an extensive paper coming out, and I know that the Comet Research Group has several papers coming out. We should point that out. This is going to be the most productive year for the Comet Research Group, I think, ever. And there are, two pending papers right now from them. And I think Dr. Moore has another 2. So there are 4 papers, perhaps, I think even up to 10, if they all got out this year, could be published this year. So it is going to be a strong, strong year for that research. Have you read those papers beforehand, and what do they tell us?
So I've read a couple of them. I haven't actually read the Abu Huraira papers yet. I'm looking forward to that. But basically, one of them is laying the groundwork for future shocked quartz evidence.
Yes.
Traditionally, it's not thought that air bursts can produce shocked quartz because of the relatively lower pressures involved compared to impact cratering events. But the Comet Research Group has pretty good evidence from 2 atomic bomb detonations and the Tunguska event and the Tal el Hammam event that these events can actually produce shock quartz. So that's one of the things we're working on. And sorry, go on.
Well, I was going to say, I know going through the evidence can be tedious and difficult, and it requires a lot of attention to protocol. But you think other people around the world would be doing this. And what's shocking is that no one is looking in recent geological soils for any of this evidence for past catastrophes when it is available to us around the world. And yes, it takes some work to derive the data, but it's not beyond the abilities of an average lab. So there's so few. In fact, I think 100% of the people who are working in recent geological soils are on this call, because it also includes Ken Tankersly up in Ohio. And Ken was looking at a much more recent event around 400 AD, just 1600 years ago in the Ohio Valley. Ken, could you give us some insight, and how does it relate to the Comet Research Group's work, and what can you do in the future to strengthen your hypothesis?
Absolutely. That's a good segue. I got involved with the Younger Dryas research because of my decades of research at a place called Sheridan Cave, which is one of only 12 documented well-dated radiocarbon dated, well-stratified, deeply buried sites on the planet. It's also one of the few places on the planet where you can literally put your finger on the end of the last ice age. And there's a burned area with a very thick carbon mat at that layer, as well as we have over 100 different species associated with the late Pleistocene. And what was interesting to me is that a lot of people misunderstand the impact of the Younger Dryas. For example, at Sheridan Cave, only 2 species go extinct, only 2 out of hundreds. What we see is a response to the Younger Dryas impact is one of 3 things. First of all, any species that survived the event that had the ability to stay, they stayed and survived. They could still make a living. Species which could not make a living in the environment that was left behind, they moved to a new location where they could survive. Others who stayed downsized. For example, the bison, we know genetically that what we used to call bison antiquus is actually the same as the bison today. It just downsized. It's what we call clinal variation. And those that could not stay, downsize, or move, they went extinct. So the punchline for the Younger Dryas is climate change. What we didn't understand was that within one human lifetime, that the climate changed rapidly, profoundly, and dramatically. And given our papers that we've published on the impact over the past decade, for example, the massive burning, Sheridan Cave was very close to the airburst site. Think about the burning event. Well, have you looked at New York City today? That's just a little forest fire. Imagine the Younger Dryas. In other words, climatically, it was a global, essentially climate changer. And one of the things I started thinking about is people have not looked at more recent times. And for me, when you look in North America, throughout the archaeological record, there's one time period where you see a plethora across a widespread area of meteorites. And I said, can that be an accident? Well, meteorites are a valuable trade item. Well, if that's true, which it is, then why weren't they traded throughout prehistory? Why at just this one small timeline? And then I started thinking, people do not use the type of geochemical techniques that we use. For example, using ICP mass spectrometry to look at trace element platinum or iridium, or microscopic evidence of micrometeorites, microtektites. So I started looking at Hopewell sites for these kinds of evidence, and I found it. In addition to seeing entire villages that were in buildings that were burnt at every site I examined. And once I looked at the radiocarbon dates, including ones we've obtained, they occurred at the end of Hopewell. Now, did a cosmic event destroy Hopewell people? Of course not. No more than the Younger Dryas made species go extinct. What happened was there was a change in the environment. During the Younger Dryas, there was a change in the climate. Some species could not adapt. Some livelihoods could not survive. And that's what we see during the Hopewell. All of a sudden, these massive earthworks, world-class earthworks, they're no longer made. The livelihood, the culture changed. And what was really exciting to me is that Native Americans had documented this across tribes in their oral histories. And since then, I've used, and Vine Deloria Jr. pointed this out early on. Since then, I've used other Native American oral histories to identify other cosmic events, and I'll be talking about those at the Cosmic Summit.
That's awesome. I want to switch over to Russ Allen a little bit. So how you, Russ?
Doing good.
Yeah, tell us about your presentation, Unfinished, and kind of what Egypt taught. You studied Egypt pretty carefully for years before actually traveling there, and now having seen it a couple of times, you've come to even kind of deeper understandings of how mysterious some of the things you see over there are. Give us a taste of what you're talking about and your relationship with Egypt and evolving understanding.
Yeah, we've been interested in Egypt and other places with similar massive megalithic structures for decades. And then in 2021, Ben invited us to go on one of his tours to Egypt. So we got to go see it in person. Now, Kyle and I are both builders. We've built a lot of things. We also operate heavy machinery. So we know a little bit about construction and also moving heavy loads. And when you get to Egypt and you see it in person, it changes how you think about it, and it kind of focuses your ability to ask the proper questions. And that's definitely what happened to us. So the presentation I have is about tying together a couple of sites with similar patterns of construction methods, discussing possible ways that they may have done this, and also showing that these sites that have these patterns tend to be almost complete. Like whoever was working on them got close to the end of the project and then all work stopped for some reason.
Right.
And there's similar sites around the world. I showed that at the end of the presentation, but the bulk of it is about Egypt and identifying the patterns. And then also it's somewhat complemented by the work that Ben is doing with Alex on these precision vases, because that allows us to take another look at these sites and say, okay, now we have really good evidence that sometime in the deep past, it's possible that people were working with very difficult materials doing precision work. So we may be able to take another look at some of these enormous megalithic sites with that, even though they were working with gigantic blocks, they were doing very precise things with them on a similar level as with the vases. So that's what the presentation is about.
Man, I can't wait to see it. I've talked to others who've seen it, and they said it's a really, really a good show. And
thank you.
Yeah, that it's fascinating. So we'll see it here in about a week. Hey, I wanted to switch over now that we've kind of defined some of the data-driven science. Let's move over to a little bit of rank speculation that used to be over in the total woo-woo corner of science and intellectual pursuits, and that's Atlantis. But the amazing thing is, for thousands of years, people have been speaking of a catastrophe in the past. Plato defined in his own time, said that 9,000 years before my grandfather's time, we had a tremendous catastrophe, and that matches exactly up to the end of the Younger Dryas, which is a coincidence, which is just a little bit, it's hard for me to believe that can be a coincidence. An ancient philosopher like that can line up his time with exactly what Marc Young's discovering using forensic data in soils is just astonishing. So I wanted to ask maybe Jahannah and Luke a little bit to talk about how Atlantis has kind of moved from something that's, clearly in the kooky aisle to something that now that we've proved the catastrophe, it legitimizes the research because it would have been so traumatic. We could have easily lost track or evidence for a culture that might have had a lighter touch than our own. So Jahannah, maybe you could talk a little about her understanding of what I call a precursor civilization and what many call Atlantis.
Yeah, I'm fully claiming the tinfoil hat for
the
summit. I'm going for it. I think that part of the fun of this is imagination, and that's why I call my talk "What If," because I'm like, let's just all put all the politics aside and let's just have fun here. Okay, what if? And I'm going through. I've reread all of Plato's works, and I'm finding all of the evidence, all the clues that Plato sort of points out. And then I'm trying to find any evidence through science or outside of Plato, and seeing if anything aligns, looking at the locations, looking at the geographical stuff at the locations of the possible sites of Atlantis, and seeing how it all weaves together. And the cool thing is that it actually does. When you step back and look at it like a big patchwork, it is all linked. Everybody's work here is actually linking. And I'm going to fingerprint and touch on a little bit on everybody's, and it really does. And then I've been working with AI because I haven't seen anybody do this, but trying to get AI to show us, okay, well then what did it look like? What could it look like? If some of these artifacts that Ben's studying and some of these structures that we can see today, like the ruins of them, what if they were inspired by previous ones or they were legacy artifacts? And I've been trying to input them into AI. I've been fighting with it because it doesn't like it, because AI literally cannot conceive what I'm trying to ask it to do either. But I've managed to get quite a good couple of images. And I'm really excited to show everybody, like, just
they're stunning. We
fantasy
can't wait to
side.
see them. And I know that's going to be an audience favorite, knowing this crowd. They like imagination. And by the way, we've got a really active Telegram thread for attendees that are already starting to coordinate, their weekend.
I've jumped in today. I've jumped in to say hi.
Thank you so much. Thank you so much. And anybody else is welcome to jump in too. People are excited to hear about your work. Hey, Luke, tell us a little bit about your presentation and kind of your take on Atlantis as someone who's, in a scientific discipline and being trained in it. Is it difficult to speak about such wild and woolly things? And what do they say around the school about that?
Right. Well, I am a cultural anthropologist, so I am a scientist, but with being in cultural anthropology, you have to take into consideration the culture that you're looking at. You have to take into consideration their, mythologies and the legends that they believe, because a lot of times there may be some woo-woo that's wrapped up in it, but there's some kind of truth there that can lead you to an archaeological site, things like that. So when I first got into anthropology, I was studying ancient Egypt, which is that's everybody's biggest interest, right? Mm-hmm. And so pretty much went all the way down the rabbit hole that everybody else here is familiar with, that the sites, a lot of the sites in Egypt really don't match up. The explanation as to why there are no reliefs and hieroglyphs in Giza and around 2600 or 2560 BC, but then just about 100 years before that, you have Djoser along with his architect Imhotep building the Saqqara necropolis, and you go down into and Ben probably seen this with his own eyes, and maybe some other of you guys have. There are hieroglyphs depicting Djoser, or maybe they've been removed and taken somewhere else in the world, but there are hieroglyphs depicting Djoser in the afterlife, in divine sanctuaries, this, that, and the other. So the timelines don't really match up. And I went down that rabbit hole. And then one day I just started studying Mesoamerica. I wanted, wanted to start looking into something else as well. And going from studying Egyptology, which is totally defined, I'm going to get into all of this in my presentation. The study of Egyptology is totally determined by the way classical archaeologists began that study. In classical archaeology, which I'll say here, this is basically the origin of it, since I'm basically the first person that's going to talk about cultural anthropology or something to do specifically with ancient civilizations. At the beginning of my presentation, I'm going to talk about where does classical archaeology come from. This is something I studied that's in school. I took several classes on this, and basically I'll talk about, so from 8000 BC and before, but starting in about 8000 BC, you have people of the Green Sahara. And so the Sahara was green at the time. And we know this because there are, rock, there's a bunch of rock art, deep within the most remote arid areas of the Sahara Desert that depicts animals and hunter-gatherer people, nomadic people, living amongst animals that we only see. Many of them are extinct, but we only see these animals in sub-Saharan greener places kind of around the Congo. And so archaeologists are able to see that and go, okay, so this area was green at the time. So there's a cataclysmic climate change, where the Sahara just becomes dry, just like that, maybe over the course of a couple thousand years. So everybody goes south, or they end up along the Nile River. And the same thing happened in Mesopotamia, down to Pakistan and India. So you got the Indus Valley, you've got the Twin Rivers, Mesopotamia, and you've got the Nile Valley. And so archaeologists approach this and they go, okay, so civilization only happens, and this leads to Atlantis. Civilization only happens when there's some kind of cataclysmic event that pushes everybody towards the same place. And because they all need to live along a source of fresh water, they don't build outward, they build up. So you build vaults and you build houses, things like that. Yeah. And so their view, and this is kind of what established, academia, the mainstream and whatever, is that civilizations are only born out of necessity, or as I say in my presentation, settlement out of necessity. But when you go to Mesoamerica, when you come to the other side of the world, take all that and throw it in the trash, because it's not even the same. So what I study is I study the Maya of the Belize Valley for the most part, but there's other sites. And when you study the Maya, the reason I call my presentation Mayan Atlantis is not because I think that the Maya are connected to Atlantis, but because there are some similarities in the way that I think we study the Maya that we should turn and look in the old world. And so all of your preconceived ideas of what you think civilization should have been doing, throw it all away, because just in Belize alone, but all over Mesoamerica or Mayan sites, they had everything that they needed to survive. They lived in a paradise. The reason that, you know, archaeologists say people of the Green Sahara, when it was tropical, they never built cities because the Sahara was lush. They didn't need to do that. They had their own farms. They didn't need to build cities. Well, in the world of the Maya, they had more than what people had in the Green Sahara, and they still built cities. You know, they still expressed themselves, and they still built ceremonial centers and giant plazas. And I list a site named Cerros that's in Belize. They built it right on the ocean next to a freshwater river. So they had fresh water, they had fish, they had wild game, they had all the fruit, all the vegetables you could possibly want, sweet potatoes, corn, this, that, and the other. They still built cities. And so I go down the list of revelations that Mayanists have had when they're studying civilizations here, and how it just, oh, well, that doesn't go along with classical archaeology. So I could go on and on about that. But then I also get into some of my own personal experiences and some things that have made me think about, you know, they always say, well, there's no ruins in the Sahara, this, that, and the other, even though there's been very little actual funding to see if that's true or not. But some of my experiences in the jungles in Mexico have just made me think about a few things. And I'm kind of just putting this on the table for somebody like a geologist to pick this up and maybe look into it.
I agree.
Hello, Professor Wickremasinghe.
Hi. Yeah, I almost thought I lost you. I didn't get the right date or something, and I telephoned you, but finally we made contact. Anyway, I was listening to that presentation with great interest. I'm no expert in any of the archaeology that he was talking about, but it reminded me of some stuff that I've been reading maybe 2 or 3 months ago on the disappearance, very sudden disappearance of the classical civilizations in the Indus Valley, the old Mohenjo-daro in the north of India, Harappa sort of in the middle of India. And they were stupendous civilizations. They had buildings that, I mean, these Sahara, the stuff that was talked about was underground now. It's buried deep in the sands, but these are standing above the surface of the earth, and have been very little explored after Englishmen, essentially about 100 years ago, excavated this area and found these. Now, what struck me was that the similarity in time between the sudden demise of these two civilizations, right? That's a mystery, and no one knows what happened. There was a cataclysmic event that led to their sudden disappearance, and the question is what happened to the people and the civilization that was extinct there for thousands of years. And there are some recent studies that have indicated, just only sort of barely indicated, that these people migrated to the south of India, and they are the Tamils of the southern provinces of India. Whether that's true or not, I keep an open mind, but it is amazing that there is a very, very extensive literature and script in these archaeological sites that have been not deciphered. There have been no funding for it, and there's very little interest and so on. But there's very elaborate scripts, and some people have said that they're related to an Indian language called Tamil, but I don't really know whether this is true or not. But
that's great that you are still on the hunt for mysteries.
Oh, the
mysteries. You think you would have been exhausted by science right now? You've been through so much since the early 1960s.
No, science is just, it's enthralling, isn't it? You can't get away from it. Only today, I think I sent a tweet when I heard that there was a a galaxy at the rim of the observable universe that has complex organic molecules, right?
Yeah.
And what I said in my tweet was, this isn't it crazy that these guys admit that there are organic molecules and they do not connect it with life? Because we see organic molecules in the soil. If you go out in your garden and dig and you see loads and loads of organic molecules, you don't hesitate to say that these are the sort of byproducts of living processes. Yet you see the same molecules in the deepest depths of space, and the traditional astronomer claims to be mystified. He doesn't know what it means.
Chandra, for people who aren't familiar with your work, I recommend it. And it is an absolute wonderful constellation of ideas and data that reaches back to the 1960s and your decades of collaboration with Sir Fred Hoyle. And indeed, I might add that Chandra was awarded a member of the British Empire by, I suppose the royal family does that, don't they? Just last year.
By the king himself.
The king himself. I mean, what a wonderful honor, and we are so.
That's the best.
That's fantastic. That's fantastic. And I tell you, a lot of our talk about comets and things from space that have affected Earth, it's been bringers of death and bringers of destruction and extinction. But your work defines comets also as bringers of life. Could you explain that to us? I think there's your philosophy and approach.
Well, I think the question of how life emerged anywhere in the universe remains an inexplicable mystery. It is so, the arrangements in life, in biology, if you take the amino acids or the nuclear components of nucleic acid, of DNA, they have to be arranged in such a specific order, both for proteins and for the DNA, to make anything like life, right? And if you work out the chances, the probabilities of this coming together in the right way by any random chemical processes, you can forget about it. You need trillions and trillions of years, trillions of cosmic universes to even think of making this happen. So I would conclude from the complexity, sheer complexity, the molecular complexity of life, that life is universal, is cosmic. It's almost part of the fabric, like the electrons and the protons, and so on, and the components, the atomic components of the universe. So forget about the origin of life. I think the origin of life is cosmic, and what happened here on the Earth is very clearly defined in terms of, and we've been talking about this, in terms of a sequence of catastrophes, right? The Earth was formed from collisions of planetoids and asteroids and comets and so on in the early sort of 4.5 billion years ago, right? And around that time, when the Earth had sort of coalesced into a solid object and was still being pounded by comets and asteroids, we now have evidence from those ancient rock formations that life in the microbial life, microscopic life forms, suddenly emerged in that milieu of collisions, right? And you can't get away from that. I mean, there are evidences from Australia, from Canada, from everywhere that this happened suddenly. And the traditional story is that there was an organic chemical brew, a factory of organic molecules, carbonaceous molecules, and that they, by some magical process, got together and became a living organism. And as I said earlier, this is such an exceedingly improbable event that I would say you have to really believe in fairies in your back garden if you're going to believe that. So that didn't happen. So it really means that the comets that were hitting the Earth in their final gift to the Earth brought the microorganisms to the Earth, right? Brought the first life to the Earth. And ever since, we've had injections of living organisms, cataclysmic events, and also maybe more quiescent events that brought the genes that made up all of us and all of plants and animals and so on that we see around us. So the architecture of life that we all we are and we enjoy, we're all part of a cosmic, I would say a cosmic plan. It's their plan in the universe. And the Earth was just one of trillions of receiving stations, right? We know now that there are millions of Earth-like planets or habitable planets, even in our own Milky Way system, in our own galaxy. So, so these things are distributed, the components of life are distributed, and they get assembled in a predetermined way, right? The predetermination comes from the information that is already in the system. And so we get ourselves and we get the insects and stuff like that. So that's what I think we have to conclude from the enormous amount of evidence that's pointing in this direction. And yet, our scientific pundits like to turn away from that and say that, oh, wait, we're just seeing fragments of organic molecules that maybe eventually would become life, but they're not life. So I think there's an incredible amount of arrogance, ignorance, stupidity that is involved in the system that, in the sociological system that we are facing.
And Chandra, your conclusions are that that even comets could contain living material, and actually they would be abundant in it. Could
Absolutely.
you explain how can such things? I think I understand after reading your work for so many years, but when people first encounter it, they're like, "Well, things can't live in space. We all think of space as just a lifeless void that would destroy anything living instantly. So how in the world do you say that life is omnipotent out there?"
Well, comets are if you look at a comet now, or if you analyze an asteroid, or these asteroids have been studied recently, they are solid objects, they're rocky objects, right? But when you analyze what the interior of those objects have been and even are at the present time, there's ample evidence for liquid interiors, right? Okay.
Yeah.
There are comets that are exploding in the outer regions of the solar system. I think there's one famous comet recently, and they're sort of essentially cosmic breweries. They're full of bacteria, full of life, and they, from time to time, they explode, and they throw out this life that components of life, right? Highly organized bits of living material that can then infect and fall onto the surfaces of habitable planets, and that's what happened on the Earth. And I think that's what's going to happen on any habitable planet that develops anywhere in the universe. So all the comets and asteroids look very dull at the moment. I mean, the surface of these things are just look like lumps of ice. The evidence from lots of modern studies, contemporary studies, is that there are heat-producing elements already on the surface that tell you that there's been radioactive heat sources that have been warming the deep interiors of these comets for billions upon billions of years. So they're not by no means, most of these things are not dead objects. They're repositories of life. They're repositories of living microorganisms. And so that's the story that we've been trying to develop through.
I've always been amazed by the disconnect, because UFOs and aliens are so popular now for good reason.
Yes.
But there's a certain class of people that would sooner believe that aliens enter your bedroom with probes.
Oh my God!
Than would believe that comets are actually balls of microbes and bacteria and stuff, right?
Yeah.
There's more of a bias against microbial life in space than there is against actual beings. I think they've got that in reverse.
Yeah. I think, George, you're right. You're right there, and I think it's just our visual perceptions. We can see the tyrant. We can see the guy who looks like an alien, even if he's sometimes a human these days, right? We see people, the criminals and so on, and we see pictures of aliens, right? Images of aliens, but we don't see the microbes because they're below our visual limit, and so these remain under the radar in our psychology. And that's the reason that we've got to be educated. We've got to learn about the preponderance of microorganisms. If you take the life that exists on the Earth, I think something like 99% of the total mass, biomass, is microorganisms.
Yeah.
I can't exactly remember the number, but 99.9, very, very, and it's only a minute mass fraction of life on the Earth is humans and animals and insects.
Mm-hmm.
So microorganisms dominate the living scene on the Earth by a huge factor. And so this is something that we don't immediately see, but any simple experiment that you do, you immediately recover that piece of information. Go to the stratosphere, take a bucket full of the stuff in the stratosphere, bring it down, and you discover that every single day, stuff that rains down on the Earth in the mist, in the rain, in the fog, and so on, contains billions upon billions of bacteria. And where do they come from? Still come from outside. These comets are still with us. I mean, we don't need to see a comet. We know that comets deposit the stuff, minute bits of stuff in the stratosphere. They fall through the stratosphere and they fall on the surface of the International Space Station. They have been discovered on the International Space Station recently. And America, and your colleague, your countrymen, essentially don't like that because it was discovered by these dreadful Russians.
Well, it was the most underreported story of the last 20 years, is that the Russians swiped the exterior of the space station, the actual big viewing window, swiped the outside of it with actually a simple tampon, and swiped it 10 times over 6 years and came up positive for microbes and biological material each time, published a paper, equivocated on whether it came from above or below. It had an unexplained mechanism from it coming from below. And then the lead researcher with the Russians on the equivocation paper then published a paper with you, and TV Grapenikova said, and this is a person who has their hands on material from the space station. These are not kooky scientists, just to have that material. And she published with you and said, unequivocally, she believes that it came from above.
Yeah, absolutely. I mean, there's absolutely not a shred of doubt that this is the case. And we still keep on doing experiments to try to find more evidence for that in the stratosphere. But to get funding for probing the stratosphere for microorganisms coming from space is almost impossible. I think there's a deep bias against life being outside of the Earth, except, as you said, I mean, aliens, okay, UFOs.
Oh yeah, it's okay.
They're okay, but these guys have to remember that if not for microbes, UFOs won't exist.
Yeah, that's right. First things first. First things first.
If you believe in the standard story of how life evolved on the Earth as a miracle on our planet, then forget about UFOs. There couldn't be a second miracle on that scale anywhere in the universe, anywhere in the entire history of the universe. So
I'll tell you what, it's funny, it wasn't intentional, and obviously this is not a UFO conference, but it's going to touch on it because it's interesting stuff. That we've got extraterrestrial lifers represented at the Cosmic Summit in two figures. One, yourself, and you'll be speaking on Saturday. But then the first speaker, on Sunday, the first speaker on Saturday is Micah Hanks. And he's one of the few that didn't join us on the call, but he is justifiably excused because he is caught up right now in a global maelstrom of extraterrestrial disclosure and revelation. And that Micah broke the story. If people aren't aware of it yet, you will be. The mainstream's starting to pick up on it, but it is out there. That on Monday, a whistleblower came forward that worked at the highest levels of the intelligence agencies, actually conducted the presidential daily briefings.
and said
went
that
through the proper channels as defined by Congress to reveal that they had been involved in programs related to alien technologies. And Congress passed a law last year that said you can come forward and there'll be no retribution, and you'll be protected as a whistleblower. So it took a while for this gentleman, and there are others out there, to work his way through that process of going to the Inspector General of the intelligence agencies and then to the Senate Intelligence Committee. And then Micah Hanks, who is speaking at the Cosmic Summit as the first speaker on Saturday, broke the story on his website, The Debrief.
Yep.
So he's at the absolute cutting edge of some of the craziest disclosures and revelations that we could possibly imagine, with actual physical craft. This gentleman, David Grush, claims, and I think it seems very, very credible. As incredible as it is, he is a credible person. And if you go lie to the Inspector General, that is a federal crime. I don't see why somebody in distinguished government service who served in Afghanistan, et cetera, would dare do that. So Micah has broken that story, and we don't know what he might tell us next week. This is his very first public appearance, and we're lucky to have him, and it makes a great book in it.
Remind me of the date, George, because I'm getting very confused on the calendar. But I mean, if you can send me an email on the time and the date of this meeting.
Yeah, you're Sunday at 8 a.m. And I will.
Sunday. Sunday. That is
That's
3 days.
right.
3 days
That's
from
right.
now. Okay.
No, a week and 3 days.
A week and 3 days. Okay.
Yeah, on the 18th.
Anyway, I mean, the fact that these have been, all the UFO reports have been declassified was a major breakthrough a few years ago, but nothing happened after that, isn't it? They were declassified and they're just left there without any comment. And it's only now that the correct interpretation is being aired by. It's taken a long time, isn't it?
I think you're muted, George.
Excuse me, I had to go to mute for a second. I've got a little activity here in the household. But hey, guys, y'all have been, as always, this team has been generous with their time, extremely generous. And I cannot thank you enough. You've stuck with this show through thick and thin. We're going to have a wonderful, wonderful weekend next week. And, in closing, I'd like to do a little bit of a lightning round. And I'd like to ask each of you, who are you interested in meeting and sitting down and talking with, if you get a moment, or maybe over dinner, other people who are going to be speaking at the conference that you might not know well now, but look forward to meeting. And I'll start with Chris Cottrell. Chris, who are you looking forward to getting to know on a personal level? Well,
I've got to say, I'm looking forward to meeting Randall. It was back in 2015 when he first started, or not first started anything, but he was on the Joe Rogan podcast. I heard him there. I happened to be in grad school at the time for geoscience, and some of the things that he was saying just clicked right into what I was learning about working in my master's classes. And so I'm really looking forward to meeting him and having his ear for a little bit. So
that's awesome, man. I don't blame you at all. Well, Randall, let's turn over to you then. Who are you interested in?
Well, I got to say, going back to the late 70s, early 80s, I owe a debt to Chandra, because I was reading Cosmic Life Force, Evolution from Space, the books that he co-authored with Fred Hoyle. Made a huge impression on me, 40 years ago. So definitely Chandra's been high up on my list of folks.
That's awesome.
But yeah, there's nobody really here that I've met a few of the folks already. Ben, of course, and Russ and Kyle. We've shared a lot of adventures together. I couldn't single anybody out, because everybody here is, somebody that I.
Well, I'll tell you, next year we're going to get Chandra in person.
I think having a virtual meeting is sort of a second best and interesting, but we really should be in a room or in a venue together, and that should be the.
Well, you're the first speaker on Sunday at 8 a.m. and I imagine not everyone will be in attendance at that time. But really, I wanted to get you on this, frankly, selfishly, for the oral history part of it. I think the more that is recorded of your thinking, the better. And I just wanted it to be a part of the show. So, Dr. Moore, are you interested in meeting any of these people?
I want to meet Ken and Martin because I'm very interested in the work that they're doing, and I want to learn more about it in person from them. But Marc reached out to me a little while ago, and so we've been in touch remotely, but we haven't had an opportunity to get together in person. And I'd like to talk to him and learn more about his ambitions for the future.
That's terrific.
George,
Marc, who do you want to have the deep conversation with?
Well, I'm looking forward to meeting everyone here, but if I had to pick one or two, it'd definitely be Randall and Andrew. Randall's one of the people who is responsible for me even being here, so it'd be great to finally meet him and have a chat. And definitely Andrew, because I have a lot I can learn from him. Absolutely.
Yeah, absolutely. Ben, how about yourself?
Well, it's a similar story. I'm looking forward to meeting everybody that I haven't met here. I have a particular interest in the published, meeting all of the published scientists that are coming. I'm very pleased that we've got this mix of people. I've been a fan of a lot of that work, and I've read a lot of the papers. If I had to pick someone, probably Marc, just because we've interacted quite a bit over the last several years, and I'm really looking forward to meeting him in person.
Yeah. Jahannah?
Gosh, everyone. Well, I feel like I've met everybody before because we've talked so much this year. I'm going to Göbekli Tepe this year, so I really want to wrangle Martin and anybody who's also been to Göbekli Tepe to really like prep me for what I got to look for, what I got to like see with my own eyeballs. So yeah,
that's terrific. Let's see, who do we have? Hey, Ken.
I would like to meet all of you in person and have a heart-to-heart.
Next year, Chandra.
Yeah, next year. We have to do that before it's too late, isn't it?
Mm.
Before the aliens get here.
Before the aliens come and take over, yeah.
I mean, there's so much hype now on AI. I think the real aliens are what we should be talking about, isn't it? They are maybe not a threat, but they've got to be admitted. Their reality has to be admitted, and we've got to take them on board.
Yeah. No, just close it. Hey, Snake Brothers, who do you want to have a beer with?
Chris. Definitely want to hang out with Chris and have a beer, bro.
Yeah, that's right. It's been a long time coming.
Yeah.
Yep.
That's great. Hey, like I say, y'all could not, have done me any greater favors than make yourself available today and all the other times. And we're going to bring it to a big, wonderful conclusion next week and hopefully set the stage for things in the future, because I think we've got a model here and we're proving it right here. The PhDs that are absolutely in the mainstream, interacting with people who are fans of their work, but also have speculation in regard to its implications, I think is just a tremendous model and needed now. We need to mix it up a little bit more, and we don't have to always agree, which seems to be, a universal requirement at most gatherings these days. But we're going to come through things from a lot of different perspectives. And I think the audience is going to receive it well. And I think we'll build a foundation to grow on. So I just love all you guys and I appreciate it. Go ahead, Randall. And any closing comments?
Very quickly, I just wanted to a little caveat here, because I think that my talk is not going to be about sacred geometry per se. Just I'm mostly going to be focusing on the deglaciation process, and I'm going to be looking at geomorphology. It's going to be heavy on geomorphology, using features in the landscape to trace the patterns of melting, and then to ultimately suggest that we can use that as a tool to determine tentative impact sites into the ice sheet.
And I tell you, Randall, I didn't give you much time to
be about.
Yeah, you didn't get a lot of time because we've got a lot of people on here to talk about your stuff, but you have a lot of time at the summit, and we're going to use up every bit that you will give us, okay? And that includes perhaps coming on stage in a less formal manner after dinner on Saturday night, if you'll do that with us. But you'll have 2 hours before then, and if you want to go longer after dinner and come back on and give some more slides, you're absolutely welcome to.
Sweet.
Yeah, you've got all the time we can give you, buddy. And we hope there could be a lot of good back and forth with the audience and the other speakers during those less formal times. I've seen that happen at conferences. I want to see you and Scott interact, on his material and him on your material.
And
so
I want to interact with Chris, because a lot of this, my interest in catastrophism, does go back to studies of the Carolina Bays in the early 1980s.
Yeah. There's a lot of cross fertilization here already, and there's more to come. Thank you, everybody, for joining us today. And
Thanks,
I
guys.
cannot wait to see you in North Carolina next week.
Thank you.
See you in Nashville.